Hello everyone, this is Child's Math 3, assignment 3 I believe. So we're going to try and get through as many questions as we can in the time that I have to record this. So, first one, if you just plug in for W, right, and you try and take the derivative as is, you'll get e to the 8s squared minus 3r squared times 5r squared times s squared, and then it's over z, which means you're flipping it, so you're multiplying all this by s squared over r. Now if you shove in your numbers, you're going to get e 8, s is 1, minus 2 squared, so 4 minus 12, times 5 times 4, so 20, times, yeah, that's it, times 1, I guess if you want, all over 2, so it's going to be e, and this is really elaborate for no reason, and then it's minus 4 times 20, so negative 80 over 2 equals e to the negative 40. So you're taking the partial derivative with respect to x from e to negative 40, which is just 0. Now I did it a much more complicated way, but you could do it the same way as that. Okay, directional derivative equals gradient, which we represent with this. Okay, so what we're going to do for this question is we're going to take all of the different gradients, so with respect to, so at f with respect to x, at f with respect to y, and the partial derivative of f with respect to z. Now the first one we can do will equal, so the derivative of x, which is the first one, so y cos 8yz. Now this one will equal, just to make my life easier, it's going to be cos 8 yz times x minus sine 8yz times 8z times y times x, and then finally the partial derivative of f equals negative sine 8yz times 8y times y times x. Okay? Now our gradient equals partial derivative of f, and then over the respect of partial derivative with respect to x times I plus times f over y j partial derivative with respect to f over the partial derivative with respect to z, I should say, times k. Okay, so that's the official definition of a gradient. But because we're being told to evaluate it, let me read the question, to at the point 7, 4, 0 in the direction of, sorry, it's too crowded, of I minus 2j plus k, right? Then we have to alter this formula, okay, to reflect that. So we could just evaluate with respect to 7, 4, 0. So the first one, because we have cos, and 0 is z, then we're going to have cos of 0, which is 1. So it's just y, which is just 4. Okay? Partial derivative with respect to y is going to be, once again, this first term is going to represent 8. The cos part will be 0, will be 1. And you just have x, so you're going to have 4 minus, hold on, yeah, 4 minus 0, okay, because the whole other portion will just be 0. So you have 4 here again. Well, I feel like I'm saying this wrong. Oh, sorry, y. Okay, so yeah, so this part's 7. Yeah, I know I was saying something wrong. 7, so this part's 7, okay, And then this last part is just going to be 0 once again. So now that when we go to represent that in our actual vector, we plug in our coefficients like instead of like j and k. So now we're going to evaluate at the direction. So we had 4 for I, so we're going to have 4 times I minus 2 times 7 plus 0, right? Sorry, this is just 4. We're just taking the coefficients at this point, okay? And this equals negative 10. And because we're being asked for like for the directional derivative in the directional derivative of the function in the direction of the vector, we have to put this in like with respect to like I guess we'd be putting this as a unit vector because we have just our regular function. Honestly, I don't exactly know if I 100% understand this because we're putting this negative 10 here, right? And then we're putting this over the normal of the gradient, which is we have 1 squared plus 2 squared plus 1 squared equals root 6 equals negative 10 over root 6. So this was my answer, but if anyone can explain to me why we're putting this pretty much as a unit vector, then that'd be crazy. But yeah, it's question number 3. Maximum rate of change, instantly go to gradient, okay? So if we go once again to evaluate our gradient, so the partial derivative of f with respect to x equals 2x plus 8z. Partial derivative with respect to y equals 12, no, my bad, equals 6z squared, and then the partial derivative with respect to z equals 8x plus 12yz. Now we can go to evaluate this at our point, okay? So the first one will get 2 minus 8 equals negative 6. Second one will get 6 times 4 equals 24. The third one will get 8 plus 12 times negative 1 times 2 equals negative 16. Okay? And then after this point, oh, hold on a second. Okay, yeah. There we go. Because it's z, so it's just 6. So you plug in negative 1 squared equals just 6. Okay? And we want the maximum rate of change. So we're going to be looking to evaluating this like as a, like, I don't know, we're going to evaluate the normal of this. So I guess if you're looking for the maximum rate of change, it's going to be the normal of the gradient of f, which equals, after everything's plugged in, we have negative 6 squared plus 6 squared plus negative 16 squared equals 2 root 217. Oh, 2 root 282. There we go. Okay, sick. Going on to 4. A little bit longer. Okay, so find the rate of change. So first we're going to take the partial derivative of t over with respect to x. This equals negative 8x times 100 over 4x squared plus y squared squared. And the partial derivative of t with respect to y equals negative 2y times 100 over 4x squared plus y squared squared. Okay? And now we're just going to evaluate this at our points, 3, 7. So if we go to do that, I plug it in my calculator really quick. Negative 8 times 3 times 100 over 4 times 9 plus 49 squared. So we're going to get negative 96 over 289i. And hold on, I want to pull up my actual solutions. Like my actual answers, because I don't know whether I'm coping or not. 1 second, guys. Okay. Assignment 3. Yeah. Okay, so negative 96 over 289. And this second one is negative 56 over 289. 289j. Okay. At this point, we are now going. So this is one thing that wasn't exactly made clear to me. We're doing the same thing that we did in question number 2, where now you're multiplying it with respect to like the direction vector. And so the direction vector, oh, actually this makes more sense now. So the direction vector, if you're finding the rate of change at this point, would be negative 3 over 4, and then this is over the normal of these points. Well, let's call that v. So you take negative 3 squared plus 4 squared equals root 25 equals 5, and so you multiply both of these. Where do we go? Okay, I went too far up. But yeah, so we got 5. And so now we're going to add these up and multiply both of them by like their respective values. So the first being negative 96 over 289 times negative 3 over 5 plus negative 56 over 289 times negative 4 over 5. This equals 512 over 1445. Okay, which for me was 0.3543. Okay. Now we're looking for the unit vector. So this is just, so u, the unit vector, over u, the vector, over the normal of u. Okay. So we already got u, the vector, like u, the vector, right? Now we're just looking for the normal of it, which would be normal of u equals root 96 over 289, negative of course, plus negative 56 over 289 squared. And then you put, for this vector, if they're asking us to put it in symbolically, you put in negative 96 over 289, grab this, not cut it, copy it, paste it again. So you have this first one, you have negative 56 over 289, and this is correct. And then the third one, finding the maximum rate of change of t at that same point, would just be the denominator. So it would be this portion evaluated, which equals, for C, 0.3846. Remember, you're just evaluating this part. Okay, number 5. See what we did here. So number 5, you are asked to find an equation of the tangent plane to the graph. So you ideally want to have this as represented as a function. And so to represent it as a function, we're looking to isolate for 0. So for f, x, y, z, we have ln 98 z squared plus 200 x squared minus y6 plus minus 8y. okay? At the point 1 over 20, 0, 1 over 14. Okay, so we're once again going to look to take it's asking us for the tangent plane, so we know we need to take the gradient, or the derivatives. So we got to do the partial derivatives. If we do the partial derivative with respect to x, we're going to have 400x squared over 98 z squared plus 200 x squared. And then when you evaluate this at 1 over 20 is 0, 1 over 14, you're going to get 1 times 20 equals just 20. So now the partial derivative with respect to y equals negative 6, y to the 5 minus 8 equals just negative 8 because y is 0. And finally, the partial derivative with respect to z equals 196z over 98z squared plus 200x squared equals 14 when you evaluate it. Now, you're going to evaluate it at like the corresponding points. So by that, I mean we now have 20, negative 8, 14, right? This is after we've plugged in our point, okay? And so we have the coefficients for the plane equation, okay? Which would be 20x minus x naught plus, that's fine, negative 8 y minus y naught plus 14 z minus z naught, which equals 20 x minus 1 over 20, right, minus 8 y, or y minus 0, plus 14 z minus 1 over 14. Okay, they're asking us to put it with respect to z. Okay, so let me add a page here. Okay, so now you're going to have 20x minus 1 minus 8y plus 14z minus 1 equals 0. Now, solving for z, we're going to have 14z equals 8y minus 20x plus 2. Okay, and then solving finally, we get 8 over 14y minus 20 over 14x plus 2 over 14, which equals negative 10 over 7x plus 4 over 7y plus 1 over 7. Okay? This is question number 5. Moving on to 6, which was a shit show, in my opinion. So they don't exactly, I don't know, I didn't feel like this was kind of like easy to break down and understand, but this is your surface, okay, and this is your plane. So we want the tangent plane, which means we're going to have to like take the derivative, at least we know guaranteed of this, to get it into the tangent plane. Now, you also have to take the gradient of the surface, which wasn't exactly kind of clear to me, in my opinion. But, I mean, we're just going to go about doing the question and seeing how it works out. So if we take the derivative of both of these, we're going to have as the surface 2x 20y 8z, and then as the plane we're going to have, so we're trying to find a point, right? We're trying to find a point on the following surface. So if you're given your plane, then I'm assuming your plane times some random coefficient will give you a point on that plane. That's kind of my understanding from linear algebra. I'm not the best when it comes to these abstract maths, but so if we say like there's lambda, let's just use lambda, okay? And to be honest, there's a solution I found online, but I'm going to try and explain it and go through it to the best of my abilities. So taking the derivative, we're going to have 10, 140, 48, and then both sides of both of those will become 0. Okay? Now, if we solve for x, y, and z respectively, okay, we're going to get x equals 5 lambda, y equals 7 lambda, and z equals 6 lambda. So plugging that back into the original equation, we're going to get 5 lambda squared plus 10 times 7 lambda squared plus 4 times 6 lambda squared equals 10,544. Solving for lambda, we're going to get plus or minus 4, okay? Which means that when we go to multiply back into these original equations, we get two possible points. We get, put it like this, 20, 28, 24, or negative 20, negative 28, negative 24. And since they're telling us to find a unit direction vector that has a positive x-coordinate, this is the only one with a positive x-coordinate. The whole unit vector stuff I didn't exactly understand. But yeah, that's about it. If someone can also help me with that, that'd be a whole lot of help. Okay, so question number 7. This is one of the last kind of, working out by hand questions. Other than actually, yeah, I would say probably about the last. So they're asking us to find parametric equations for the normal line to the following surface at the indicated point. Okay. So once again, we got to solve for f at x, y, z. This will be 4x squared minus 2y squared minus z at 3, 5, negative 14. Okay, so the normal line, right? Okay. Okay. So if we want to find the normal line and we use the given point and a unit direction vector at this point we know to be u over that. Okay. So in order to find u, this would be the gradient. I should actually put it like this. Over the normal of the gradient. Yeah, that's a lot better. There we go. Okay. So we have to find the gradient, which means we're taking the directional derivative, which means that our gradient f equals 8x minus 4y minus 1. And our normal will be our gradient evaluated at the point given. Even we should also probably evaluate. Okay. We're asked to evaluate a point, so we have to plug this point in, which will equal 8 times 3, so 24, and then negative 20, and this is still just negative 1. There's nowhere for us to plug it in. Now if we go to evaluate the normal of our gradient, we're going to get 24 squared plus 20 squared plus 1 squared equals root 977. And so basically what we got here is our unit vector. Okay, so we got 24 over root 977, negative 20 over root 977, and negative 1 over root 977. Okay. And our parametric equation would be our original point, x0, plus our direction vector. So x yeah, x equals x naught plus v times t. In this case, this is our v. And so we do this for all of them. So our curve will be original point 3 plus 24 over root 977, and then negative, oh no, it's not negative. It's 5 minus 20 over root 977, and then it's negative 14 minus 1 over root 977, and that's that. Okay, so this question was one that I actually, I got this on the first try for both of them, and I can explain how. So this is like a similar question to Calc 3. Basically, the easiest way to do it is to just look at each quadrant. So go Q1, 2, 3, 4, etc. And literally just be like, okay, so in the first quadrant, in Q1, I'm going to have positive x and positive y. Okay, so they're both positive, which means for x equals y, right? F at x is going to be 0. Okay, that's fine. But they don't exactly, like, you can try and find the exact point, but they won't show it to you in there. More so, what I found helped was just like, look at the hypotenuse. I know that sounds weird, but seriously, just look at the direction of the hypotenuse. So in Q1, you have always a negative x, right? And a positive y. So your hypotenuse will go this way. And I just found that like all of my, I included it here. All of my like vectors in Q1 should be going up and to the left. Okay, so if I go to Q2 now, right? I now have, for Q2, I have negative x but positive y, okay? And so when I plug that in, now I'm going to get my vector going to the right and up. Remember, this vector is coming from here, like what my I is doing, what my I and j is doing, not just the values that I'm putting in, okay? And this is my answer. And you could see that, we have all of them going to the left and up, and this is the hypotenuse. And you don't even have to do these two if you get the first two, right? Oh shit, I didn't include 9. Oh, I did. Okay, good. And so similar kind of ideology here. So in Q1, right, I'm going to have, for positive, they're all positive, so I'm going to have it going down for I. Hold on. Yeah, I'm going to have it going down, and then it's also going to be going to the left, and so my hypotenuse is going to go like this. And you can see that they all go down and to the left. Even this one's still going down to the left. And then for my, left, for my Q2, I now have negative and then positive values. And so for my negative x values, I'm going to have it going to it's now going to be going up, right? And then it's still going to be going, to the left. Yeah, and then my hypotenuse will go like that. And all of them follow that trend because they're all going up like this. Okay? Awesome. So finishing off on 10. So the equation for curl, the curl of f equals the determinant, it is still cross product, but the determinant of the partial derivative with respect to x, the partial derivative with respect to y, and the partial derivative with respect to z. And this is probably how it's going to show us on our formula sheet. And then you have your functions I, your function j, and your function k. So the coefficients of those, okay? Now, remember that for each of these guys right here, okay, it's actually more than what the eye sees. So for the first one, I'm going to label these 1, 2, 3. So for 1, you're computing actually the partial derivative with respect to y minus the partial derivative with respect to z. The second one will be the partial derivative with respect to z minus the partial derivative with respect to x. And the third one will be the partial derivative with respect to x minus the partial derivative with respect to y. Okay? And when you compute this, understand that, okay, x is not a function that you are considering. Okay? So x, for the first one, is not a function you are considering. And I'm going to actually just compute the values, and I want you guys to piece it together on your own. Because I think it's much more valuable to see the pattern without me explaining it to you. So I'm just going to continue on. X times z cubed times 9y cubed, to the 8 plus 8y. This one equals 6y ln x minus y to the 9 times z cubed equals 3 minus 6z ln x. Okay? And yeah, there you go. Awesome. So after we've written down our derivatives, then we are going to plug in our values. So we have 4, 1, 5. And in our case, this will come out to 4 times 125 times 9 plus 8. Okay, and this is 4508. This one will be 6 ln 4 minus 125. This will be 3 minus 30 ln 4. And this will be your answer for A, the corresponding values. And then your answer for B, which would be the divergence. The divergence is simply just you adding up each of the corresponding derivatives. So you take the derivative with respect to x plus the derivative with respect to y plus the derivative with respect to z of each of the following functions. So the first one would be the derivative with respect to x of 6yz ln x, and this of course equals 6yz over x. You plug in the values, so we're still at 415. And then for this one, you'll get 6 times y, so you have 30 over 4. And then the second one will be the derivative with respect to y times 3x minus 8yz. This will, of course, equal negative 8z, which will be negative 40. And then the last one will be with respect to z of x y to the 9 z cubed equals x y to the 9 3z squared. Plugging in our values, we get 4 times 3 times 25, and this comes out to 3, it should be 300, if I'm not mistaken. I didn't even calculate it, I just left it as it is. But yeah, 4 times 25 is 100, so this is 300. And then you're going to add up all these values, which would be 30 over 4 minus 40 plus 300. If we do some simple rationalization here, 160 over 4 plus 1200 over 4. So you have negative 130 over 4 plus 1200 over 4 equals, I think that's just 1070 over 4. And if you divide them both by 2, you'll get 535 over 2. And this is the correct answer. Awesome. Hope you guys enjoyed, and we'll see you in the next assignment video.